Hi, my name is Abhinav Mishra, and this is my course project submission for predicting the energy output of a combined cycle power plant. So the problem statement we are trying to address here is to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. We have a set of 9,568 hourly average ambient environmental readings from sensors at the power plant, which we will use in our model. We have been provided a dataset consisting of hourly average ambient variables like temperature, ambient pressure, relative humidity, exhaust vacuum, and net hourly electrical energy output. Now talking about the machine learning approach and output metric. I assume or I perceive this as a supervised regression problem because we have a labeled data and the goal is to predict a continuous numerical value. Considering this, the models I'm planning to use are the linear regression and the random forest. Since this is a regression task, I've chosen the following performance output metrics. The mean squared error because it penalizes larger errors more heavily, and the R square score, which is which measures how well the model explains the variance in the target. The features I'll be considering for these models are the all four features which have been provided to us in the dataset, because to me all of these are relevant in determining the output of the power plant. So the temperature, ambient pressure, relative humidity, and exhaust vacuum would be the features used in the model. Now talking about the model one, the linear regression model. So the reason we are choosing linear regression is because it is simple, interpretable model that also assumes a linear relationship between input features and the target variable. So as you can see, I have used Python for modeling, and I have in this snippet of code imported all the necessary libraries and defined a data training file, which is a subset of our complete data set. And then we have set all the variables for input features and target variables. Then I'm using the linear regression model, generating the predicted value for y, which is our PE value, the predicted PE value, and then also printing the necessary mean squared error and the R square score. So the output we can see here is the mean square error is 20.54. I have also executed a 10-fold validation. So the deviation of MSE across folds is 1.68, and the prediction MSE on full data set is 20.5. The R square score on the full data set is 0.9299. Now moving on to the second model, which is the random forest. I have taken the random forest as it is an ensemble learning method that also builds multiple decision trees and averages their prediction. And this is excellent for capturing non-linear relationships. Since I have already considered one linear model, I wanted to take a non-linear model just to see which one performs better. So in this one, again, I have used Python, imported the necessary libraries for the random forest generator, provided the input data set, configured the input and target variables, and now I am modeling it using random forest generator method, and then predicting the output value for the PE, the power output, and then printing the necessary values for MSE and R square. So with the random forest, we are getting the mean squared error of 11.8 and the R square of 0.96, which looks much more efficient or performant or accurate than the linear regression. Now to summarize the output metrics and the predicted values. So the mean squared error with linear regression was 20.5, and with random forest it's 11.82, and the R square score with linear regression was 0.9, and with random forest it's 0.96. So it seems like the random forest is more accurate because it had a lower mean squared error and also a value which of R square score better than the linear regression. Since 0.96 is much more closer to 1 than 0.92, the random forest seems to be more performant and accurate model here. And I've also attached a snippet or a very small subset of the output values with the predicted values of the linear regression and random forest models. So this is from all from my side, and Please feel free to share your feedback. Thank you once again.